but I want to give you a way to think about glycolysis in a simple way. Here's how I would think about it. So you're starting with a sugar, right? This is a six-sided sugar, glucose. Your goal is to break it apart and get the electrons from it, right? That's the whole purpose of glycolysis. We're ripping apart this glucose. However, the glucose is pretty strong, it's pretty stable in its six-membered ring form. So you're going to have to put in a lot of effort to break it apart. So what do? Right? So the first thing you try is to put a little stick of dynamite on the end of the glucose. That is a phosphate molecule, a high energy phosphate forming glucose 6 phosphate. Okay. It's like a little stick of dynamite that you're putting on in an attempt to break apart this glucose molecule. So you put on the stick of dynamite to the glucose, and then you wait for a little bit and nothing happens, right? You're just left with glucose 6 phosphate. So what next? What do? Right? Well, you're pretty frustrated that this didn't work. So you take the glucose 6 phosphate, and you squeeze it really hard, and then all of a sudden, one of the carbons pops out from the ring. You go from a 6-sided sugar to a 5-sided sugar. So you've now formed fructose 6 phosphate, right? You've gone from glucose, a 6-sided sugar, to fructose 6 phosphate, a 5-sided sugar. So you have now this sugar that you just squeezed really hard. And then you look at it and it's still in its ring form, right? So what next? Well, you have another idea. What if we added a second stick of dynamite to the other end of this molecule? Now remember, there's only 6 carbons. If we're attaching the dynamite, it'd be best if we attach it at both ends. In other words, carbon number 1 and carbon number 6. This is going to give us our fructose 1,6 bisphosphate. Now, you attach those 2 sticks of dynamite, but yet there's still nothing that's happened. So what do, right? This time, rather than squeezing it really hard, you decide to pull. You take one phosphate with one hand, the other phosphate with the other hand, and then you pull it apart really hard, really hard, really hard. Finally, the molecule breaks apart, okay? It breaks apart into 2 almost equal compounds. They are each 3 carbon compounds with a single phosphate attached. These 2 compounds are glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. Each of the compounds has 3 carbons and has 1 stick of dynamite, that high energy phosphate that's stuck to it. And that is the proximal part, the energy investment phase of glycolysis. We are putting in energy to break apart this very stable glucose ring. And then the second half of glycolysis is the energy recuperation phase, where we're actually starting to generate ATP as well as remove those electrons, forming NADH. So that's how glycolysis is divided into those 2 parts. We're putting in some ATP currency, that high energy phosphate, those sticks of dynamite, if you will, adding energy to the system, breaking apart the glucose, and then extracting the electrons from those fragments and using them to make ATP.